Hello, everyone. Thank you for being here today. We're going to talk about building location-based AR apps. So just a bit about me. Currently, I am an engineering director working with Google Play in Atlanta. If you want to reach out to me at any point, please reach out to me on LinkedIn, and for now, on Twitter at Erica Stanley. And so even though for my day job, I'm not doing a lot of either XR or aeronautics work, in a previous life, I did quite a bit of both. And so in undergrad, I did a lot of VR research, and that kind of led to my grad and academia time of doing XR research. And I worked really closely with a literal rocket scientist as we were trying to understand and optimize sensors for different mixed reality environments, while also creating simulations for any of the shuttle experiences. And so took that to some work that I did at Kennedy Space Center, where I got to do some direct space shuttle work, again, working with visualization of the space shuttle at different trajectories. So you're trying to figure out, like, with different atmospheric conditions, what happens to the space shuttle's trajectory. And so I did that for a time and then moved out of the academic space. And then recently, I'd say 2 roles ago, got back into my mixed reality past with Mozilla and worked with the XR team there. And there I worked with Firefox Reality and led those suite of teams for quite a while. We had an iOS version, we had an Android version, we had a web version, so we made sure that this was something that was really accessible for folks, no matter what platform you were using. And then I transitioned to another team, the Hubs team, that was doing a lot of social mixed reality platform work. So in the same way that you might have conversations over Zoom or Meet or any of the video conferencing applications out there, we created a 3D environment for people to engage and to choose their avatars and to choose their environments and to collaborate in 3D space. And you could do that with a headset, or you could just do that over the web or with your phone. So even though it's not something that I do for my day job, it is something that I nerd out about quite a bit, and I try to keep my foot, one foot in the door of mixed reality. And I've also, again, been a space nerd for quite a while. So this talk kind of combines some of my nerd goals, some of the AR from my mixed reality past, and some of the space and space shuttle work that I've done in the past. So what should we do if we're space nerds? What would be a good way to kind of get back in there, which is like dipping your toe into this world? And so I've been doing a little bit of stargazing recently. I'm a super newbie, and wanted to understand, what do I even need to get involved? So I was really excited to learn that I didn't need to buy some expensive equipment right away. If you are monitoring the conditions where you're trying to do your stargazing, you can see a lot of the stars and a lot of the astronomical events that you're trying to view with the naked eye. Now, there are telescopes and binoculars and special cameras that you can get once you get more deeply ingrained into the community, but you don't have to do that immediately. So I was really excited about that. And then you want to get to know the night sky, especially around you. What are the kinds of things that you can expect to see, the kind of constellations, the planets, the kind of events that you might expect to see in your region of the world? So you kind of want to go back to the basics. What are the planets, and how are they aligned and positioned in the sky? How are certain constellations aligned, and how can you locate other constellations, other events, meteors, that kind of thing, even though you're kind of viewing with the naked eye? And then you want to kind of keep up with the astronomical events that are happening. So there's a whole calendar of events that you can kind of keep up with. For instance, in this area, in the southeast region of the US, there are a few events that you might want to look up. So there's a blood moon that's going to be visible for the next few weeks. There are also a few meteor showers that are going to be available for the next few weeks, so this is pretty timely if that's something that you're interested in. Then as you're starting to get set up for your, say, first stargazing adventure, you want to make sure that you get your eyes adapted to the dark so you can actually understand what you're viewing. And then you want to make sure that you can reduce or avoid light pollution. And this is actually a really big deal. So the Bortle dark sky scale is actually a scale that people use, especially in astronomy photography, to understand, how much of the sky they're going to be able to see. And so this one on the extreme side is something that you're probably never going to see. There will always be some light that does cause some pollution. But then as you go up the scale, you'll start to see 2 is something you might see in a rural area. 2 and 3 are things you might see in a rural area without a lot of light pollution. And then 4 and 5 are something you might see in the suburban areas. And then once you get to 6, 7, and above, you're getting into your more urban areas. So this is a light map of North Carolina. So you can see wherever any of the cities are, you start to see a lot of white, you start to see a lot of red, and those are going to be areas where it's going to be really hard to view any of the stars and constellations in your area. So you're going to want to find the areas where there is blue or like a darker blue. Notice around the coast, you get this really nice kind of view. So if you're ever at the beach, this is a great time to do some stargazing. So now that we've determined like stargazing could be something we could really get into, what could we build that would help us in our stargazing journey? So let's think about some things that we want for our stargazing app. First, we might want precise position and rotation so that we can understand where we are in this environment and what is the light pollution value of my location. We might also want to understand, we might also want to drop anchors to share with other stargazers where we've been and what constellations and what events we've seen at those locations. And you might just want to journal your stargazing adventures. So those are the kinds of things we might want to do with this app, but let's first understand AR, let's first understand some of the concepts, and then we'll get into how we would actually start to implement this in our app. So let's just walk through a little bit of AR. So I think a lot of folks see XR, VR, AR, and don't really understand that they're very different. And they're kind of a scale. So you can go from something like augmented reality where you still have your physical space, you still have a camera where you can see all of your physical space, but you're also augmenting your environment with digital objects and digital interactions that would not normally be there if you were just looking through your camera. And then you have mixed reality, which is kind of this mix of digital elements that can interact with the physical elements in the physical environment. And then you have on the other side of that scale, you have virtual reality, where this is a fully immersive digital environment. And so this is just an example of something you might expect from an AR application, where you can see your physical environment, but you have some indicators and some objects that are somewhat translucent that you can see on your camera as well. And so if you're trying to understand technically how AR works, you might have a 3D model that you've been working on as an application developer. You might use something like SketchUp, you might use something like Sketchfab to find these models and to work with them. And then you're going to make sure that you have some kind of webcam. Now this could be on a laptop, this could be on a tablet, this could be on a phone. And then you want to make sure that you have some kind of target to let the application know where you want to place your 3D environments. And then the output that you're getting from that is this augmented physical environment where you see things through the camera in your physical space, but you also see the digital objects that you created with your 3D modeling applications. And so that's just a foundational understanding of AR. But now how do we start to think about designing apps for AR? So some things we might want to consider. We might want to think through environmental versus interaction design. So when you're thinking about environmental design, this is very different than when we're building apps for the web or we're building mobile apps without this 3D or environmental angle to it, because you have to consider how your objects are positioned against the physical environment. Can users see through these environments so that they're in a safe space, and so we don't block or occlude users from understanding that cars are coming if they're out in a very public area, those kind of things. And you also really want to think through interaction design, because we have a variety of interaction types at our disposal with a mixed reality environment that we just don't have on the web or on mobile. And so one of the things we want to think about are, what are we interacting with? We may have some text, but we may also have some animated media, and we might also have some 3D volumes. And so with any of these, you want to think of the positioning of your objects relative to the user's position and the camera. You want to make sure that you're not positioning things right in the field of view so that you've blocked most of the screen. You also want to make sure that you understand the elevation of the camera so that whatever you place is actually within the view. You don't want to have users looking all over the app, trying to look up, trying to look down, trying to figure out where the indicators and the markers might be. So you want to consider where you're placing these objects that the users are going to have to interact with. And then you want to think through the cues. What are the things that people are going to understand will help them move through this environment? What will, take them from one object in your augmented reality environment to the next? What will let them know that there's a way that they can interact with these objects? So you want to really think through those. Those could be visual cues, those could be audio cues. But if you're going to build this for, say, a mobile device, and the user may or may not, say, have a headset connected to that, you might want to think through whether audio cues are the best cues for that. And then you want to think through the color and the text. You want to think through contrast here, because you're going to be getting a lot of light, possibly from your physical environment. So you want to make sure that people can actually see the color and the text that you're placing here. And then you also want to think through the weight and the presence of the 3D models. You want to make sure that your model has the right scale for the environment that the user is going to be walking in, and for the size, say, of the user, for the size of the objects that you want them to interact with. And then you want to think through, how are you going to interact with your environment? There are a variety of ways. You could just do simple taps, but there could also be gestures. There could also be, depending on if this is for a phone or if this is for a headset, they may have a controller. So think through how all of these interactions are going to play out as you're building this, and think through what is the most organic interaction that you can encourage for your user as you're working through the UX and the design for your AR app. So these are just a few best practices that I've noticed as I've been building mixed reality apps, and especially AR apps. You want to, again, make sure that you have translucent design elements so that users can see the physical environment through the objects that you've placed in the environment. You want to make sure that you are assessing your application's accessibility against WCAG guidelines. You want to make sure that you have, high contrast. You want to make sure that you have a high contrast ratio so that people can see these objects within the environment and interact with them. You also want to make sure that you have fairly large margins between the 3D or the digital objects that you're placing in the screen and the edge of the screen. You want to make sure that the margins are about 5 to 10% of the screen size between the focus of the objects. And then wherever you can, you want to try to use physical interactions so that people can feel immersed in this environment. And another thing is, you don't want to try to do everything at once. You don't want to show all of your UI at one time, because that can be overwhelming to the user. And again, you may be occluding the physical space. So now that we understand kind of the foundations of AR, now that we understand some of the things we should be thinking about and considering when we're designing for AR, how can we start to use these things to build location-based AR with ARCore? So ARCore is Google's open source AR SDK that works well with Android, obviously, but also works with iOS. So this is a way that you can start to build and it also works with Unity. So you can get involved at any levels. Let's say you're already a Unity developer. This is something that you can integrate with AR foundations into your Unity projects. And then this is very simple to incorporate into any of your Android projects as well as your iOS projects. All of the examples here will be Kotlin for Android, but this also works in iOS. So there are a few different options that you have when you're trying to build a location-based AR application with ARCore. So you can use something like the built-in sensor. So you can use something like GPS. And so GPS is very convenient, but not super accurate. So think through that. And then you can also use something called the Cloud Anchors API. And this is, you may get better accuracy, but you're going to have it in a much smaller space. So this is very much like if you've ever had a headset where you have to scan the area where you're going to be working and playing. It's very much like this, where you have to scan the immediate area before you can actually start to drop anchors in that space. But again, you have higher accuracy, but smaller space. And then the geospatial API is something that was just recently introduced, and it kind of gives you a best of both worlds, where you're leveraging Google's global scale 3D map as you start to build out this application. So what's really interesting here is that for the many years that Google has been building up this 3D map with Google Earth and kind of driving around, Google Maps as well, driving around and kind of mapping out the 3D environment, they've used that to make sure that they can give you some additional accuracy whenever you're trying to find your location or find your pose or find your rotation within a space. So this kind of just compares those three options. So you can have global scale with GPS, and you can have global scale with the new geospatial API, but you lose some of the accuracy, the precise location, or the precise orientation as well. So one of the differences with the geospatial API versus GPS is that with GPS, for instance, you could have 5 to 10 meters of precision versus with the geospatial API, you can have less than a meter of accuracy there. So that's just to kind of give you an idea. Same thing with orientation. Orientation actually can be even worse with GPS. And so you get much more accurate location and positioning with the new geospatial API. And then, for the cloud anchors, it gives you the accuracy, but again, you can't do this remotely. It's very manual. You have to scan your space. And so with geospatial, you get the ability to kind of place your objects remotely, but you also get the accuracy that you might expect from cloud anchors. So let's talk about what we want to do with our stargazing app now that we understand the tools that are available to us. So just to review, there were a few things that we wanted to do with our stargazing app. We wanted to get more precise positioning and rotation. We wanted to understand light pollution at our location. And then we wanted to be able to drop anchors to share or journal our adventures, our stargazing adventures. And so this is an example of how you would make sure that you're getting your position and your rotation. First, you have to go into your config and enable the geospatial mode. So that's what you see with this first step here. And then you want to make sure that you're tracking. So you want to make sure that you get your Earth object and then check for the tracking state. And then you want to make sure that you get the camera geospatial pose. And that gives you all the data that you might want to use. It gives you your longitude, your latitude. It gives you your pose information. It gives you levels, scores for your accuracy as well. So you can use this code here to display this, as you see on the bottom here. And so you can see things like, is the Earth state enabled? Is tracking currently happening? And then you can get some very accurate numbers around your latitude and longitude. You can understand the accuracy. Here is 0.74 meters. So again, very different from GPS, where you're looking at 5 to 10 meters of accuracy. It'll give you altitude, which is something that's really interesting, because on top of this, there's a terrain model where you can start to say you want to take your stargazing adventures to some mountain hiking, right? And you want to be able to show other users the different terrain and different elevation that they may see the best constellation, let's say. And so this is something that we didn't have before, where we can start to include elevation in our measurements. So that was making sure that we were getting more accurate positioning and rotation for any of our movements within the space. And then let's say that we want to journal our stargazing adventures with anchors. Well, first we need to check to see if there's already an anchor attached. And if there is, we want to detach it, unless we're going to do, say, a collection of anchors. So if you're going to do multiple anchors, then you wouldn't necessarily want to do this step. Something I want to call out here is making sure that the altitude is the same as the camera's positional altitude. That means that this will appear within the user's camera view, and it won't appear in some area where they won't be able to see it later. You're going to want to set the quaternion of your anchor. You should already have your latitude and your longitude and your altitude from the screenshot I just showed you, and then you add your quaternion to that. And then you're going to want to view that, and then you'll see something that looks a little bit like this. And so these markers, these 3D markers that you can drop here, you can find those anywhere you can find 3D models. So I use Sketchfab a lot for various 3D models. Sometimes I create my own if I want something really custom. But this is something that you can kind of drop into space, and it can kind of represent where you've been in your stargazing adventures. And depending on how you set up the interactions, you can also kind of make a scavenger hunt out of this, right? So you could do something where you wanted someone in your stargazing community to check out all of the areas you've been to, or the constellations you've seen and where you've seen them. So this is something where you can keep this for yourself, or you can share this with your community. And so that's pretty much, it's very simple to get started with this library, with this API. And so I added a few resources that helped me as I was exploring this. And one was a video for VPS and the ARCore geospatial API. One was the Code Lab, the geospatial Code Lab. When I was getting into stargazing and I wanted to understand what does that even mean? What do I need to do? I checked out this Stargazing 101 article. If you want to learn more about light pollution, especially if you want to, for instance, get that latitude and longitude and add that to a light pollution map to get that value so that you can kind of plan your stargazing adventures, then this light pollution map is just lightpollution.info. And then this is a link of upcoming astronomical events. I mentioned the blood moon that was coming up. I mentioned the meteor showers that are coming up. So in case those things are interesting to you, check them out here. And that's it.